Hello viewers, welcome back to my channel. Today I'm going to be teaching you the structures of alkanes. I'm going to start with the homologous series itself. Alkane is an homologous series, and I will show you the molecular formula of each members of the group, which is called homologs. Now, alkane has a general molecular formula of CnH2n plus 2, and the first member is methane. So we have methane, the second member is ethane, propane, butane is the fourth one, pentane is the fifth one, hexane sixth, heptane seventh, octane eighth, nonane, and decane. Now, using this general molecular formula, I will substitute each position in based on the series for n. Now, if n is 1 here, for methane I will have 2 multiplied by 1 plus 2. So I have C1H4, which is CH4. So methane is CH4. The next one is C2, 2 multiplied by 2 plus 2, that is 6. The next one is C3H, 2 multiplied by 3 plus 2, that is 8. And next, C4H, 2 multiplied by 4, 8 plus 2, 10. C5H, 2 multiplied by 5 plus 2, 12. C6H, 2 multiplied by 6 plus 2, that is 14. Followed by C7H, 16. C8H, 18. C9H, 20. C10H, 22. Now, so you have to learn this series because it will be useful for other members of the alkanes and alkyne series. Now, from this point now, the next thing is to learn how to draw the structure of each of these molecular form, each of these homologs. And I'm going to use butane as an example. If I want to draw butane, which is C4H10, I have my C on a straight line, 4 C's. Then at the edge of each of the carbon, at the carbon at the edges here, will be surrounded by 3 hydrogen, because each carbon is supposed to be surrounded by 4 hydrogen. You can see 1, 2, 3, 4. 1, 2, 3, 4. So at the edge here you have 3, while inside you have 1. Now for this one now we have 1 hydrogen, 1 hydrogen, 1, 2, 3, 4 as well. So that is how and why alkanes are saturated. That is, all their bonds are filled up with elements, and there is nothing like double bond or triple bond in them. So alkanes are single bonded, meaning that they are saturated. They are completely filled with atoms. Now, this is N-butane, that is a straight chain butane. Now, if you can do the same for decane, just draw your 10 carbon and then surround the edge with the carbon at the 2 edges with 3 hydrogen, and then the 2 hydrogen in between. Now, I can rewrite this as CH3, CH2, CH2, CH3, or CH3, CH2 into brackets 2 because it's appearing twice, then CH3 outside. This is also the structural formula. Structural formula shows the spatial arrangement of elements in a compound, while it shows the arrangement of elements in a compound, while the empirical formula shows the simplest ratio of atoms in a compound. The molecular formula, on the other hand, shows the exact number of atoms of elements in a compound. Each element that makes up that compound, the exact number of atoms present there. That is for the molecular formula. And so before we move on, we need to learn a special group called the alkyl group. This alkyl group will help you to be able to identify or name an organic compound easily. And this alkyl group is 1 hydrogen short of the alkanes. So that is CnH2n plus 1. Alkyl group is not an homologous series. It only helps in naming organic compound. So the first member as well is methyl. methyl here is 1, 2 plus, this is C1, 2 multiplied by 1 plus 2. That is CH3. The next group is ethyl. That is C2, 2 multiplied by 2 plus 1. That is C2H5. The next one is propyl. That is C3H7. You will notice that each successive member increases by CH2. The same thing is happening here. Then the next one is butyl. Butyl has C4, 2 multiplied by 4 plus 1, that is 9, and so on. So the next is pentyl, C5H11, and so on and so forth to get to like 10. Now, using this, we can now go to this side where we want to name this hydrocarbon. There are some rules that need to be followed anytime we want to identify an organic compound. And the first rule is identify the functional group of that compound. Is it single bonded? If it's single bonded, is alkanes. Is it double bonded? If it is double bonded, is alkanes. And if it's triple bonded, is alkynes. Now, if it has OH at the edge or anywhere, it is an alkanol, and so on and so forth. So looking at this now, we can see that there is a single bond all through, and apart from this single bond, we can see that there was an attachment somewhere here and here. Now this attachment looks like Alkyl attachment, but the second rule states that we should count the longest root chain, that is the longest carbon there, which may not even be the one on the straight line. So looking at this now, which path could have the longest root hydrocarbon? Already we know that this is an alkane. So let's count 1, 2, 3, 4, 5, 6, 7. That is on a straight line. But if you pass another route, 1, 2, 3, 4, 5, 6, 7, 8. I think the longest route here is on this direction. So that is an octane from number 8, using the general molecular formula, octane. So because this is an octane and it's a single bond all through, that's why it's an alkane. And so it's in position 8, octane, because it has 8 carbon. Now, the next thing is to rearrange it. So it means that instead of this acting as a substituent, that is an attachment, this will act as the attachment. So we have something like CH3, CH2, 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 C 1, 2, 3, 4, then C2H5. This is acting as attachment attached to this CH2 here, which is still here. Then we have the last part, which is C3H7. So if I want to redraw this or rename this, I can change it to CH3 like this, CHH, HH, HH. Now, the issue here is that this is hydrogen, and it is one hydrogen. There was a mistake here. One hydrogen is attached to this carbon, and then we have C2H5 here, which is acting as an attachment. And then this C3H7, I can also rearrange it or break it down to give CH2, don't forget it's C3H7, then CHHH, that is C3H7. So looking at this, we can name our compound easily as 1, 2, 3, 4, 5, 6, 7, 8. That is octane. And the octane is attached to a substance. So we need to count the number of atoms. We need to get the number of atoms that this ethyl group is attached to, because it's actually an ethyl, C2H5, that is attached to this octane. Now, if you count from this side, and we count from the other side, that's on the left side, and from the right side, we are going to settle for the least number. So counting from this side, we have 1, 2, 3, 4, 5. Ethyl is attached to carbon 5. But counting from this side, we have carbon 1, 2, 3, 4. So we have it on carbon 4. So we are going for carbon 4. That is the rule. So in this case, we have 4 ethyl octane. That is the name of the compound. So the next compound here is simple and straightforward. We have 1, 2, 3, 4, 5, 6. Is that also an octane? And then we have CH3 here attached. Then here we also have CH3 attached. So here we can write this as CH2. I'm trying to expand the structure. So having something like this is also writing it as CH3, CH2, CH, CH3, CH, CH3 as well, CH2, CH3. So don't be scared. Now, instead of 2 hydrogen attaching itself to this carbon, methyl has taken the place of one of the hydrogen. Another methyl has taken the place of the next hydrogen here, instead of having CH2 here as well. So that is what is happening in this case. So the substituent attached to this hydrocarbon, to this alkane, is methyl, that is CH3, and we have it in 2 different places. So let's count the longest hydrocarbon: 1, 2, 3, 4, 5, 6. So there's no other routes. So we have 6, that is hexane, and the hexane here has 2 substituents attached to it, the same group, methyl on one side, methyl on the other side. So let's determine the number of carbon in which this methyl is attached to. Starting from this side, we have 1, 2, 3, 4. That is 3, 4. On this side too, we have 1, 2, 3, 4. That is 3, 4. So they have the same number from both sides, so we can use any of the side. So it means that methyl is attached to carbon 3 and 4 of the hexane group. And in this case, assuming you have another group attached, like propyl attached to it, now we have 2 different groups. I'm just assuming. So indeed, this is methyl, M, and this is P. Which one comes first? M comes first. So methyl will be named first before propyl. Now, if it is ethyl, that is C2H5, E will be named before M. But in this case, we have CH3. So we are going to use 1, 2, 3. That is 3, 4 hyphen dimethyl, because we have 2 methyl attached to this structure. Hexane, that is the structure. So watch out for my next video, which is on alkanes. And if you are here to subscribe to my channel, please press the subscribe button below the video, like and share my videos to others. Thank you.